Hello, everyone, and welcome to day 10 of the Jamb Physics in 40 Days series. This is a series brought to you by Oyalen, where we believe that when you dedicate within 30 to 45 minutes of your time daily, you'll be well on your way to acquire all the necessary skills and knowledge you need to prepare adequately, not just to pass, but to ace Jamb Physics. So if you are preparing for the Jamb examination and one of the subjects that you have selected in your subject combination is physics, then this video is definitely for you. Trust me, you don't want to miss any of the videos in this series. So please check it out from day one, where we have been treating different topics per day. So you don't want to miss any of those topics. Check from day one and follow the video up until this video, which is day 10. And those of you who have been following the video, I want to say a big thank you to you. Please keep your questions coming. Always drop your questions in the comment section, and we will definitely attend to each and every one of your questions. Now, day 10 is about pressure. And as far as pressure goes, what you're expected to understand before the exam is the concept of atmospheric pressure. Now, pressure generally is defined as the ratio of force per unit area. So when we say atmospheric pressure, we are looking at the force exerted per unit area on the Earth's surface by the weight of the air in the atmosphere. Now, some of the things you need to understand there is things like the concept of density, pressure. You must understand relative humidity. You must understand relative density as well. Now, another thing that is expected that you understand is pressure in fluids, especially when it comes with the relationships between pressure, density, and the like. So you have pressure equals height, density, and acceleration due to gravity. This equation is going to come in very handy in this topic. So let's just go ahead and look at different ways that Jamb has set questions on this topic in the past, and then we'll definitely solve them. However, if you want a deeper understanding on this topic, you can do well to check out our video specifically on pressure, where we explain pressure in fluid in details. So please check out the video so that you get a fuller understanding. But if you're ready, let's just go on to solve past questions from Jamb on this topic. This question from the 2000 UTME says, at a fixed point below a liquid surface, the pressure upward is P2, and it can be deduced that now we have options such as P1 is greater than P2, P1 is greater or equals to P2, P1 is less than P2, and P1 is equal to P2. Now, this relates to what is known as the Pascal theory, right? And when we look at the Pascal's static principle here, we know that at any point within a liquid, the pressure is often distributed uniformly. So according to that principle, the pressure should be distributed uniformly at any point within the liquid, right? So therefore, we see that at any point you pick, the pressure at that point will be the same as the pressure at any other point within the same liquid. So P1 should be P2. Now, if you want to look at it from another dimension, you could also look at the gas laws or fluids law, right? When we consider that, we know that in this case, the volume is the same. The temperature at all points too should also be the same. So if pressure and if temperature and volume rather are the same, therefore the pressure should also be constant. So P1 equals P2. So we go with option D. Now this question says, when cold water is poured on a can containing hot water, the can collapses because now this is a very fun experiment that is often done in the lab to show relationship between pressure, temperature, and volume and the likes. So when you have an aluminum can, for example, and then you add water into it and then heat it up, as you heat the aluminum can up, the water within it begins to become converted into steam still within the can, and the steam will occupy the space that is in that can. Now when you take away the heat and then you pour cold water onto the can, now what happens is that because of the action of that cold water, it will cool down that steam so fast, the temperature will drop very fast. And as temperature drops, if you look at the relationship between temperature and pressure, you will see that they increase and decrease at the same accord. That is, they're directly proportional, right? So when the temperature within the can drops, the pressure in the can will also drop rapidly, which will make the atmospheric pressure, that is the pressure around the can, to become significantly larger compared to the pressure within the can. So it is because of this that you see that that can will immediately crumple up like that. So when we consider the options provided here, we see that the one that explains that concept is D, which says external pressure becomes greater than the pressure within the can. And it's because of this reason that you see that the can crumples up, or as the question says, collapses. So we'll go with option D. This question says, if the partial pressure of water vapor at 27 degrees Celsius is 18 millimeter of mercury, and the saturated vapor pressure of the atmosphere at the same temperature is 24 millimeter of mercury, then the relative humidity of at this temperature is, so we have to find the relative humidity. Now, relative humidity is given as the saturated vapor pressure at dew point over saturated vapor pressure of atmosphere multiplied by 100%. Now, this is given as 18 millimeter of mercury. Now divide by that of the atmosphere, that's 24. Then we multiply this by 100%. So mmHg cancels out. What goes here? That's 6 goes here 3 times, 6 goes here 4 times. So what we have is 3 over 4 times 100%. So relative humidity is therefore 75%. So the correct option therefore is option C. This question starts with 4 statements. We have density of the liquid, 2, acceleration due to gravity, 3, type of container of the liquid, and 4, the constituent of the liquid. Now the question itself reads, which of the above conditions will not affect the pressure of a fluid? Now when we consider the pressure of a fluid and those things that it relates with, the pressure relates with the depth it is, and then it also relates with the density as well as acceleration due to gravity. Now, looking at the conditions we have here, density is mentioned, acceleration due to gravity is mentioned, depth is not mentioned at any point. So what we have here is type of container of the liquid and the constituents of the liquid. And these do not have any bearing on the pressure of a liquid or of a fluid generally. So in this case, the only ones that affect the pressure is density and acceleration due to gravity. That is 1 and 2 only. And looking at the options provided, that is option D. Now, this question from the 2009 UTME says, if the pressure of vapor on top of an enclosed liquid is equal to the atmospheric pressure, what will be the temperature of the liquid enclosed? Now, what this means is that if the saturated vapor pressure is equal to atmospheric pressure, and when these two are equal is when a particular liquid can then boil, right? So if saturated vapor pressure is equal to atmospheric pressure, then that liquid that is enclosed is definitely boiling. So the temperature where it is will be called the boiling point. So we go with option B. Now, this question says, in an hydraulic press, the pump pistons exert a pressure of 100 Pascal on the liquid. Now, what is the force exerted on the second piston of cross-sectional area 3 meter squared? Now, so let's look at what we are given. we are told that the pressure exerted is, that is pressure P is 100 pascals. And then we are also told that the area, the cross-sectional area is 3 meters squared. Now, and we're asked to find the force. Now, the relationship between these three parameters is that pressure equals force over area, which implies that force would be pressure multiplied by the area. So let's find the force then. The pressure, 100 pascals, multiplied by area, 3 meters squared. And this will give us 300. And the unit of force is in newtons. So 300 newtons is our answer, and that is option A. Now, this question says, the accurate measurement of relative density of a substance in its powdered form is done with a beam balance, and that is when you have a particular material in its powdered form, for example, like sand, and you're asked to find the relative density. You need to measure the mass and then to find the density of the material, and the apparatus we use for that is known as the density bottle. And for the other options that are provided here, the Eureka can, for example, is used to find the volume of a material that has a regular shape. For the pipette and then burette, we use it to measure volumes of liquids, like when you're doing your titration. A pipette has its own measurement already. It can be that 20 cm cube or the 25 cm cube pipette. But for the burette, it is graduated, so you can easily measure any volume you want as long as it is within the range that that particular burette has. So of all these options, the only correct one is option A, a density bottle. A hydrometer is an instrument used for measuring. Now, take note of this. While you use the density bottle to measure the relative density of solid materials in the laboratory, now if you're trying to find the relative density of a liquid, what you'll be using in that case would be a hydrometer. So the correct answer here is in option D. That is, a hydrometer is used to measure relative density of a liquid. This question from the 2010 UTME says, the density of a certain oil on frying becomes 0.4 kilogram per meter cube with the volume of 20 meter cubed. Now, what will be its initial volume when its initial density is 0.8 kilogram per meter cube, assuming no loss of oil due to spillage? Now, this final statement lets us know that the mass of the oil remain constant from start to finish. So to solve this, we're going to apply that density equals mass over volume. So let's say density, initial density equals mass over initial volume. So from here, we can say that the mass is therefore initial density multiplied by initial volume. And the same thing can apply to the final density and final volume. So I can say mass is also equals to D2 multiplied by V2. So if both are mass, I can equate them. So therefore, density 1 and volume 1 equals density 2 multiplied by volume 2. So since the question is asking us to find the initial volume, V1, so V1 therefore should be D2, V2 multiplied by D2 all over D1. Now, V2 is given to us as 20, yes, 20 meter cubed multiplied by the final density 0.4 kilogram per meter cubed